Okay, hi all, Mr. Stemple here, and today we're going to talk about the Bridge Designer software. So let's start with how do you get that software. Go to bridgedesigner.org, and it looks like this, and you can download it. It's free software. It's pretty easy to get. You'll have to install it on your computer, but should be pretty easy to find. And then once you do that, you can go right here and click it up. It's 2016 version. It's 4 years old, but no big deal. And it gives you these little design tips whenever you first start up. You can read through them if you want. I'm just going to go ahead and close it. And then it's going to ask you, what do you want to do? Do you want to create a new bridge design, or do you want to load a sample design? For now, I'd like you to load a sample design so I can show you how it works. I'll go ahead and say OK. And the one that I want you to use, because it's really easy to see, is this one right here, the Pratt Deck Truss Bridge, 44-meter span. And that looks like this. So that's a real bridge somewhere. I don't know exactly where, but it's the design of sort of a real bridge. So click OK. And now we have that bridge. So before you do anything else, if you want to run the simulation, you can go up here to Test and down to Load Test, and it'll show you what it would look like if a truck drives over top of that bridge. So you can see here that some of these beams are pink or red, and some of them are blue or darker blue. The ones in blue are in tension. The ones in red or pink are in compression. So I'm going to stop that animation. It'll just keep going if you let it, and go back to the drawing board here. So for now, what I want you to do is just try out a couple things. So the thing that I'm going to try is I'm going to use number 6 right here, and you'll see over here on the right, every beam in this bridge has a number, and it has all the details of that beam right here. So number 6 is a bar. That means it's solid. Its size is 260 millimeters by 260 millimeters square, and its length is 4 meters. So what I'm going to do is just make a quick change to that. I'm going to go right up here to the top, and I'm going to reduce it down to 160. Now obviously that makes it smaller. You can see how much smaller it made it there on the diagram. And then I'm going to go to Test, and I'm going to do a load test and watch what happens. So it's really red, which means, there it goes, which means it's under a lot of compression strain. So it's being pushed from both sides. And what happens when it's pushed too much from both sides? It buckles in the middle. So when it buckles in the middle, this truck obviously can't drive across it, otherwise it'll fall into the water, which would be a bad idea. So I need to go back over here to the drawing board, and you can see that right here it's got a big red box that showed my compression was too much for that beam. So I'm going to put that back where it was, click on it there, and put it back to 260, which is where it started at. I got to click on it. There it goes. Back to 260, which is where it started at. That gets back to its original size. And then I'm going to go down here and click on this one on the bottom, which is number 17, and I can see that its size is 200. So I'm going to change its size. I'm going to reduce it down to 100. Okay, making it much smaller. So then I'm going to do this again, test, load test, and you can see before the truck even drives across it, it's broken. See, it got really dark blue, and then it fell apart in the middle. That is too much tension. So it's being pulled here, it's being pulled there, and so it breaks it in the middle even before the truck gets there. So go back to the drawing board, and I can see that it's showing that it has too much tension. So what you'll notice is there's a lot of numbers here. These beams here are most of them are under tension. Most of these beams up here are under compression, and you can see the compression numbers. Now later we'll get into what these numbers mean, how they differ as something drives across it, etc., etc. But for now, I want you to just play around with that. After you've done that, then you can go ahead and make as many changes as you want. So your assignment for this assignment for today, this week, is that you make a bridge that is as cheap as you can make it, but still holds up under the stress of that truck driving over it. So the way you do that is you look up here on the top, And you can see that my bridge right now costs $502,458.10. If I click on this one right here, because I need to fix it, I need for it to go back to where it was. It was up at 200, right? You can see that that brings my price up. So I took my price up to 509. So obviously, bringing that down to 100 was not good. Maybe I can try it at 180. So I can bring that down to 180, reduce it a little bit, which reduces my price a little bit. Let's see if it works. I'm doing it under the load test. I can see that it's got a little darker, so it's got a little bit more, got a little bit more tension on it, but it's enough that it doesn't break. So your goal now is to reduce the size of these, reduce the cost of these, to see if you can make your bridge be cheaper but still hold up under the tension. So see what you can get to, and take a screenshot when you're done and show me how much your bridge costs. I want to see who can get the cheapest bridge. Now obviously when we're building bridges in real life, we don't necessarily just want to make them cheapest, we want to make them best, because there's all kinds of other forces and such in play here. But for now, for this exercise, I want to see how cheap you can make this bridge and still have it hold up under that truck. Good luck.